The theory of evolution dates back to the age of classical Greece, and from time to time philosophers have offered the evolutionary explanation of the origin of the multiple forms of life on Earth, as opposed to the theory of special creation or the permanency of living forms from the day of creation. Lamarck thought that acquired characteristics were transmissible by heredity and thus might lead to the appearance of new forms of life. In 1840, the year that Agassiz's Ice Age theory was published, an anonymously printed work, Vestiges of Creation, written by Robert Chambers, caused a stir that did not subside for years. It was bitterly attacked by every British scientist for teaching that human beings are the children of apes and the breeders of monsters. Darwin later acknowledged that the brunt of the attack against his own theory was absorbed by this earlier publication. What was new in Darwin's teaching was not the principle of evolution in general, but the explanation of its mechanism by natural selection. This was an adaptation to biology of the Malthusian theory about population growing more quickly than the means of existence. Darwin acknowledged his debt to Malthus, whose book he read in 1838. Herbert Spencer and Alfred R. Wallace independently came to the same views as Darwin, and the expression survival of the fittest was Spencer's. Darwin wrote his theory with the point of his pen directed against the theory of catastrophism. He hardly expected that no opposition would come from the side he attacked. Otherwise, he would not have expended so many arguments in combating catastrophism and in subscribing so completely to Lyell's theory of uniformity in lifeless nature. The emotions of this prolonged controversy were spent on the issue. Is there evolution or is there not? More and more scientists subscribed to evolution. Religious minds clung to the belief that there had been no change since the creation of the world. The radicals did not participate, for catastrophism was dying out with the generation of the founders and traditionalists of geological science. Cuvier died in 1832. In England, geologists like Buckland of Oxford and Sedgwick of Cambridge, set in their belief in biblical tradition, ascribed the universal vestiges of the catastrophe to the action of the deluge. But they could not point to a satisfactory physical cause of such catastrophe, and expert estimates made it obvious that, had all the clouds over the Earth emptied themselves simultaneously, the Earth would not have been covered by even 1 foot of water. In his last address as president of the Geological Society, Sedgwick admitted that his religious beliefs caused him to propagate a philosophic heresy. I think it right, as one of my last acts before I quit this chair, thus publicly to read my recantation. We ought indeed to have paused before we adopted the Diluvian theory and referred all our old superficial gravel to the action of the Mosaic flood. For of man and the works of his hands, we have not yet found a single trace among the remnants of a former world entombed in these deposits. So where were the remains of the sinful population? Cuvier taught that man's remains were never found with those of extinct animals. Lyell also declared in the first edition of his Principles that man was created after all the extinct animals passed away, and not until 1858, a year before the publication of Darwin's Origin of Species, did the finds in the Brixham Cave shatter this belief in the non-coexistence of man and extinct or antediluvian animals. In the year of Darwin's Origins of Species, the leading English geologists were finally convinced by J.B. de Perthes, a notary of Abbeville in France, who for 20 years found only deaf ears, that human artifacts and extinct animals are met in the same formations. This opened wide the doors to Darwin's theory. By that time, the doubts of the catastrophists, who could not understand why there were signs of more than one deluge and why there should be no human bones left of all the sinful generation that perished in the flood, had already brought about the abandonment of the theory of catastrophism, a theory that appeared to be in conflict with the geological record. Thus, it happened that the entire controversy for and against Darwinism failed to respond to the challenge of Darwin, who tried to show that what appeared to be the result of global catastrophes could be explained as the product of slow changes multiplied by time, with no violence intervening. But why did Darwin oppose the idea of great catastrophes in the past, contrary to his own field observations, and subscribe to the theory of uniformity of geological events in all ages and in the present? For species to evolve as a result of incessant competition and struggle for survival, all the way from the simplest forms to Homo sapiens and other advanced organisms, an enormous span of time is required. The teaching of catastrophes appeared to make the story of the world very short. If the deluge occurred less than 5,000 years ago, then, following the book of Genesis, creation took place less than 6,000 years ago. In order to have at the disposal of the evolutionary process the almost unlimited time needed, Darwin accepted Lyell's teaching, and whereas Lyell tried to show that the usual agents such as rivers carrying sediment act with comparative speed, Darwin liked to stress their sluggishness. He wrote,
"Therefore a man should examine for himself the great piles of superimposed strata, and watch the streams bringing down mud, and the waves wearing away the sea cliffs, in order to comprehend something about the duration of past time."
The waves of the sea reduce a rock, particle by particle, and if a visible change is produced, it requires many thousands of years.
Nothing impresses the mind with the vast duration of time, according to our ideas of time, more forcibly than the conviction thus gained that subaerial agencies which apparently have so little power and which seem to work so slowly have produced great results.
Darwin even went so far as to suggest that
he who can read Sir Charles Lyell's grand work on the principles of geology, and yet does not admit how vast have been the past periods of time, may at once close this volume.
his thesis of the origin of species by natural selection, Darwin supported by reference to 1. Variations in domestic animals, especially when the breeder deliberately develops a certain desirable feature. 2. The anatomical similarity of many related species. And 3. The geological record. Though breeders have created new races or variations, they have created no new animal species. In the anatomy of living creatures, the distinctness of the specific forms and their not being blended together by countless transitional links is a very obvious difficulty, wrote Darwin. And thus, the entire weight of proof was placed on the geological record. In the forms of life changing almost simultaneously throughout the world, the title of a section in The Origin of Species. Darwin wrote,
"Scarcely any paleontological discovery is more striking than the fact that the forms of life change almost simultaneously throughout the world."
This appears baffling, because according to his theory,
the process of modification must be slow and will generally affect only a few species at the same time, for the variability of each species is independent of that of all others.
Could it not have been a sudden change in physical conditions that altered the forms of life at one and the same time throughout the world? Darwin answers, no.
It is indeed quite futile to look to changes of currents, climate, or other physical conditions as the cause of these great mutations in the forms of life throughout the world under the most different climates.
If the climate or other physical conditions changed in one part of the world, how could this alter forms of life in all the other parts of the world? That a change in physical conditions could have occurred all over the world at one and the same time, Darwin did not even take into consideration. What kind of an answer to his problem, therefore, could Darwin propose?
Blank intervals of vast duration as far as the fossils are concerned occurred. During these long and blank intervals, I suppose that the inhabitants of each region underwent a considerable amount of modification and extinction.
Darwin then considered the absence of numerous intermediate varieties in any single formation and wrote, "If we confine our attention to any one formation, it becomes much more difficult to understand why we do not, therein, find closely graduated varieties between the allied species which lived at its commencement and at its close." And he found the answer in the conjecture that, although each formation may mark a very long lapse of years, each probably is short compared with the period requisite to change one species into another. Furthermore, the geological record shows the sudden appearance of whole groups of allied species, and the abrupt manner in which whole groups of species suddenly appear in certain formations has been urged by several paleontologists, for instance, by Agassiz, Pictet, and Sedgwick, as a fatal objection to the belief in the transmutation of species. If numerous species, belonging to the same genera or families, have really started into life at once, the fact would be fatal to the theory of evolution through natural selection. For the development by this means of a group of forms, all of which are descended from some one ancestor, must have been an extremely slow progress, and the predecessors must have lived long before their modified descendants. Darwin explained this observation too by the incompleteness of the geological record, which because of the gaps gives the appearance of sudden changes. The geological record of extinction of species is discussed under the heading On Extinction. Darwin wrote, "The extinction of species has been involved in the most gratuitous mystery. What took place is apparently sudden extermination of whole families or orders. According to his theory, the extinction of a whole group of species is generally a slower process than their production. And yet some groups were exterminated wonderfully sudden." Here, once more, Darwin thought that the imperfection of the geological record may in some cases simulate the suddenness of the extinction. But he acknowledged in other cases his inability to explain the spontaneity of the extinction of some species. He still wondered, as in the days of his South American travels, why horses had disappeared in pre-Columbian America, where they had every favorable condition for propagation. And in a letter to Sir Henry H. Howarth, he acknowledged his inability to explain the extinction of the mammoth, a well-adapted animal. But in general, the failing of the geological record was invoked to explain the apparent spontaneity of extinction, as well as the suddenness with which new species seem to have arrived on the scene. According to the theory of natural selection, chance variations or new characteristics among individuals of a species, if beneficial, are exploited in the struggle for survival and, being inheritable, may by accumulation lead to the origin of a new species. Because of the chance nature of these new characteristics, and therefore also of the origin of the new species, Darwin assumed
that not only all the individuals of the same species have migrated from some one area, but that allied species, although now inhabiting the most distant points, have proceeded from a single area, the birthplace of their early progenitors. The belief that a single birthplace is the law seems to me incomparably the safest.
Darwin explained the migration of plants from continent to continent and from mainland to islands by the transportation of seeds in the intestines of birds. The migration of mollusks by observed instances of small shells clinging to the legs of migrating birds. This method of dispersion does not account for the geographical distribution of larger animals unable to fly or swim across the sea or traverse climatic zones unsuitable for the species. Since animals of such species are found in very distant parts of the globe, divided by oceans, Darwin was led to maintain that during the vast geographical and climatic changes which have supervened since ancient times, almost any amount of migration is possible. This makes necessary the existence of land connections or land bridges between islands and mainlands and between all continents. But to these geographical and climatic changes, the Ice Age included, Darwin ascribed a subordinate role in shaping the development of the animals. They played an important role, but only in the migration. Where the land is continuous, as in the Americas, Darwin accounted for the fact that identical animals lived in higher latitudes of the southern and northern hemispheres, and not in temperate and tropical locations, by resorting to a theory which assumes that the glacial periods in the northern and southern hemispheres did not take place at the same time, but they instead followed one another. When a glacial period was descending upon the north, animals migrated slowly to the south, toward the equator. When the glacial period ended and the climate in the subtropics became hot, some animals returned to the north. Others remained in the subtropical regions, climbing the cool mountains. When the next glacial age, this time advancing from the south, arrived, the animals on the mountains came down, and when this age also ended, some of them moved to the south, while others again retreated to the mountains. Thus, identical animals are found in the cooler regions of both the northern and southern hemispheres. The theory of evolution by natural selection could not do well without the theory of the Ice Ages. It needed the Ice Age theory to explain the existence of the same species in the southern and northern hemispheres separated by the torrid zone. It needed it even more to account for the phenomenon of drift. Erratic blocks could have been explained, with some straining, by the action of icebergs. But drift, or accumulation of clay, boulders, and sand that in many places fills valleys hundreds of feet deep, could not have been brought in by icebergs. And finally, icebergs, in order to be produced in great numbers, themselves required extended glaciers from which they could break off. Darwinian evolution needed the Ice Age theory in order to replace the tidal wave theory, which is a catastrophic notion. Darwin accepted Agassiz's teaching, though not in its original form with a catastrophic beginning of the Ice Ages. But Agassiz rejected Darwin's theory. The reason for this he saw in the skeletal remains of ancient fish, a field in which he was an authority. In many instances, the fish of extinct species were better developed and further advanced in their evolution than later species, the modern fish included. Among mammals, too, many better developed species became extinct. But these difficulties in the way of the evolutionary theory were less strongly felt in the heat of the fight against the opponents who insisted on a 6,000-year-old world and the immutability of species. Darwin's theory represented progress as compared with the teachings of the Church. The Church assumed a world without change in nature since the beginning. Darwin introduced the principle of slow but steady change in one direction, from one age to another, from one eon to another. In comparison with the Church's teaching of immutability, Darwin's theory of slow evolution through natural selection, or the survival of the fittest, was an advance, though not the ultimate truth. The story of his experiences is told by his contemporary and adherent, Thomas Huxley.
Darwin's Origin of Species was badly received by the generation to which it was first addressed, and the outpouring of angry nonsense to which it gave rise is sad to think upon. But the present generation will probably behave just as badly if another Darwin should arise, and inflict upon them that which the generality of mankind most hate, the necessity of revising their convictions. Let them, then, be charitable to us ancients, and if they behave no better than the men of my day to some new benefactor, let them recollect that, after all, our wrath did not come to much, and vented itself chiefly in the bad language of sanctimonious scolds. Let them as speedily perform a strategic right-about-face, and follow the truth wherever it leads. The opponents of the new truth will discover, as those of Darwin are doing, that, after all, theories do not alter facts, and that the universe remains unaffected, even though texts crumble.
Natural selection, the Darwinian mechanism of evolution, is simultaneously destructive and constructive. In the struggle for existence, it eliminates all the unfit among the members of a species, and it destroys the species that cannot compete with others for the limited resources of livelihood. The winners in this struggle are those individuals that, because of some characteristic or favorable variation, have an edge over other competitors.
Under these circumstances, favorable variations would tend to be preserved and unfavorable ones destroyed. The result of this would be the formation of new species.
As is discussed in many of my previous videos, and the general theme of this channel to date, the annihilation of many individuals and of entire species in the animal kingdom took place, not only under circumstances of competition, but under catastrophic conditions as well. Entire species with no sign of degeneration suddenly came to their end in catastrophes of nature, yet extinction of a species through starvation or extermination by enemies also takes place. Moa, the gigantic flightless bird of New Zealand that stood 12 feet high, was destroyed several centuries ago. The whooping cranes of North America were reduced by 1953 to 21 individuals. Natural selection cannot account for the wholesale destruction of many genera and species at one time. It may occasionally be the agent exterminating single groups of animals, but can natural selection create new species? The geological record presents evidence that in the past, animals lived that do not live any longer, and that of the forms living today, many did not exist in the past. So how did they come into being? The animal and plant kingdoms are subdivided into phyla, and these into classes, orders, families, genera, and finally species. A species can be recognized this way. The mating of members of two different species generally does not produce offspring, and when it does, such offspring is sterile like the horse and ass, and their offspring, the mule. Thus, all humanity is but one species, and all races of dogs, so different in their body structures, are members of one species. There are hundreds of thousands of species in the animal kingdom and in the plant kingdom. In the theory of evolution, all forms of life evolved by gradual emergence from the same most primitive one-cell living beings. Chance variations occur in members of every species, and no two individuals are entirely identical. These variations are inheritable. As already explained, the favorable variations of those that are helpful in the struggle for existence may accumulate to such a degree that, according to Darwin, a new species originates, the members of which can have no fruitful progeny with the members of the parental species. Since the first scientific observations were made, no truly new animal species has been observed to come into being. The year after publication of The Origin of Species, Thomas Huxley wrote,
"But there is no positive evidence at present that any group of animals has, by variation and selective breeding, given rise to another group which was, even in the least degree, infertile with the first."
A few years later, Darwin wrote in a letter,
"The belief in natural selection must at present be grounded entirely on general considerations. When we descend to details, we cannot prove that a single species has changed, nor can we prove that the supposed changes are beneficial, which is the groundwork of the theory."
And at the end of the century, Huxley found himself compelled to make the statement, "I remain of the opinion that until selective breeding is definitely proved to give rise to varieties infertile with one another, the logical foundation of the theory of natural selection is incomplete. We remain very much in the dark about the causes of variation. In selective breeding, the breeder creates conditions not found in wildlife, and new races or varieties of animals created by selection and isolation revert to their ancestral unselected forms as soon as they are turned free. Thus, when dogs of various breeds mate, they give birth to crossbreeds which resemble their common ancestors. Despite all their efforts, breeders have not been able to cross the true frontier of a species. Then how could a new species originate in chance variations and through crossbreeding in wildlife? And how could so many new species be produced that they number, together with the extinct, in the millions? And how could a human being, so complicated, evolve, not just from common ancestors with the primates, but from common ancestors with winged insects and crawling worms? The evolutionists drew more checks on time. On evolution as a geological fact, all agreed, but on the mechanism of evolution, the disagreement has been fundamental. The neo-Darwinists deny that physical surroundings can give rise to new species. They may bring about changes in an organism, but the acquired characteristics are not inheritable. Can, then, natural selection or competition with other animals create new species? The classic example of a giraffe with the longest neck surviving when leaves are left only high on the trees does not prove that giraffes with longer necks would become a separate species. And in any event, under the described conditions, no new race would evolve. The female giraffes, which are smaller in stature, would die out before the male competitors, and there would be no progeny. But should there be progeny, the young giraffes would probably die because they would be unable to reach the leaves. The position of Darwinists would be much stronger if a new animal species would appear, even if only in controlled breeding. Darwin claimed that the process of the appearance of new species is very slow, but he also maintained that the process of extinction of a species is even slower. Nevertheless, some species of animals have expired before the eyes of the naturalists, but no new one has appeared. The theory of natural selection, even the very fact of the evolvement of one species from another, needed proof. Some scientists went so far as to say that possibly the entire development plan has already reached its permanent stage, and the geological records tell only of the road to that stage, evolution no longer taking place. But the theory of natural selection could not yield its position unless a better explanation of the evolutionary mechanism could be given. The first ray of light came at the turn of the century when Hugo de Vries, a Dutch botanist, observed spontaneous mutations in the evening primrose. The plant, without a recognizable cause, would show new characteristics unobserved in its ancestors. Although de Vries claimed that these mutations amount to what may be called little species, they have not caused the primrose to pass beyond the limit of its species. However, it was demonstrated that variations within a species do appear in a spontaneous manner, and rather suddenly, and not, as Darwin thought, by minute progressions from generation to generation. Huxley was correct in urging Darwin not to adhere so dogmatically to his belief that nature does not make jumps. De Vries showed that variations are in the nature of jumps, and from this he developed the mutation theory of evolution. De Vries, while working on his theory, was yet unaware of Gregor Mendel's investigations in genetics, already published as a paper in 1865, only 6 years after the origin of species. Mendel's work, unknown to Darwin and his followers in the 19th century, was rediscovered by De Vries in 1900, the same year that De Vries wrote down his theory of mutations. By carefully observing crossings between varieties of the garden pea and counting the strains through consecutive generations and the transmission of single traits, Mendel established the fundamental laws of genetics or inheritance of somatic characteristics. The entire work on evolution since the beginning of this century is based on genetics and Mendel's laws. The spontaneous variations in mutants can be followed through as hereditary factors in successive generations of offspring. The genes in the germ plasma are the carriers of the traits, and a variation or mutation in a gene would cause a mutation in the offspring. But generally, only single variations appear at a time. They may lead to new races, not to new species. Spontaneous mutations are far too few and insufficient in magnitude to bring about the appearance of new species and to explain how the world of animals came into existence. Despite all spontaneous variations, no new species of mammals are known to have been created since the close of the Ice Age. In 1907, V.L. Kellogg of Stanford University came to the following conclusion.
The fair truth is that the Darwinian selection theories, considered with regard to their claimed capacity to be an independently sufficient mechanical explanation of descent, stand today seriously discredited in the biological world. On the other hand, it is also fair truth to say that no replacing hypothesis or theory of species forming has been offered by the opponents of selection, which has met with any general or even considerable acceptance by naturalists. Mutations seem to be too few and far between. For orthogenesis, we can discover no satisfactory mechanism. And the same is true for the Lamarckian theories of modification by the cumulation, through inheritance, of acquired or ontogenic characters.
Thus, the entire problem was shunted back to the place it occupied before the origin of species. Evolution is the principle. Darwin's contribution to the principle is natural selection as the mechanism of evolution. If natural selection, sharing the fate of sexual selection, is not the mechanism of the origin of species, Darwin's contribution is reduced to very little, only to the role of natural selection in weeding out the unfit. L.T. Moore, in a series of guest lectures delivered at Princeton University, asked, "If natural selection is a force which can destroy but cannot create species, and if the reasons for this destruction are unknown, of what value is the theory to mankind?" The collapse of the theory of natural selection leaves the philosophy of mechanistic materialism in a sorry plight. De Vries made observations of spontaneous mutations in plants. A decade later, T.H. Morgan found spontaneous mutations in the vinegar fly, including various colorings of the eyes and various lengths of wings, and many other changes in descendants do not present in any of the ancestors. H.J. Muller, by subjecting the vinegar fly to the action of X-rays, increased the frequency of mutations 150 times. It was also found that some chemicals and temperatures close to the limits that the insect organism can endure may act as mutation-provoking agents. Muller concluded that spontaneous mutations are usually due to an accidental individual molecular or submolecular collision occurring in the course of thermal agitation, and this is indicated by the amount of rise in the frequency of mutations that is observed when the temperature is raised, so long as temperatures normal to the organism are not transgressed. Since chemical changes similar to, but more extreme than those of thermal agitation, may also be produced by X-rays and other high-energy radiation and by ultraviolet, it is not surprising that mutations like the so-called spontaneous ones can be induced in great abundance by these means, and that the number of these mutations is, in general, proportional to the number of physical hits caused by the radiation. At the beginning of the present century, it was noticed that tadpoles or embryonic frogs in the presence of a tube containing radium give rise to various mutants. Radioactivity and cosmic radiation are agents present in nature, one of terrestrial, the other of extraterrestrial origin. If, as the experiments with the vinegar fly demonstrated, A mutation of some gene can produce a wingless fly. Many mutations simultaneously or in quick succession would be quite able to transform an animal or plant into a new species. In the bomb craters of London, new plants, not previously known on the British Isles and possibly not known anywhere, were seen to sprout. It appears that the thermal action of bomb explosions was the cause of multiple metamorphoses in the genes of seeds and pollens. If this is so, then the statement made earlier that no new species has been observed in the process of making its first appearance must be retracted. Cosmic rays or charges, hitting nitrogen atoms in the atmosphere, transform this element into radiocarbon. These charges, arriving from outside the Earth, are very strong per particle, averaging several billions of electron volts and sometimes carrying a potential of 100 billion electron volts. As moderately few such rays or charges hit our atmosphere, the typical effect is not spectacular. But it is conceivable that, where a cosmic ray or charge hits a gene or germ plasma, a biological mutation takes place. Should a somatic chromosome be hit by a powerful charge, it might at worst cause disorganized growth and be the origin of a neoplasma. But if the genes of the germ plasma should be the target of a collision with a cosmic ray or secondary radiation, a mutation in the offspring might ensue. And should many such hits occur, the origin of a new species, most probably incapable of individual or genetic life, but in some cases capable, could be expected. Thus, increased radioactivity coming from outside this planet, or from the bowels of the Earth, could be the cause of the spontaneous origin of new species. Should an interplanetary discharge take place between the Earth and another celestial body, such as a planet, a planetoid, a trail of meteorites, or a charged cloud of gases, with possibly billions of volts of potential difference and nuclear fission or fusion, the effect would be like that of an explosion of many hydrogen bombs, with ensuing procreation of monstrosities and growth anomalies on a large scale. What matters is that the principle that can cause the origin of species exists in nature. The irony lies in the circumstance that Darwin saw in Catastrophism the chief adversary of his theory of the origin of species, being led by the conviction that new species could evolve because of competition with accidental characteristics serving as weapons, only if almost limitless time were at the disposal of that competition, with no catastrophes intervening. Now exactly the opposite is true. Competition cannot cause new species to evolve. Mutations in single traits and the resulting new varieties within a species are caused by radiation hitting some gene, as did the X-rays in the experiments on the vinegar fly. It is a hit or a collision or a miniature catastrophe. For a simultaneous mutation of many characteristics to occur, with a new species as a resultant, a radiation shower of terrestrial or extraterrestrial origin must take place. Therefore, we are led to the belief that evolution is a process initiated in catastrophes. Numerous catastrophes or bursts of effective radiation must have taken place in the geological past to change so radically the living forms on Earth, as the record of fossils embedded in lava and sediment bears witness. How would this understanding of evolution meet the facts, and especially those facts that always appeared to be in conflict with the theory of natural selection? The fact that some organisms, like foraminifera, survived all geological ages without participating in evolution, a point of perplexity in the theory of natural selection, would be explained by catastrophic evolution in which many species would be destroyed. Others would be subjected to multiple mutations, and some specimens of species would escape mutations and procreate their old form. The fact that the geological record shows a sudden emergence of many new forms at the beginning of each geological age does not require the artificial explanation that the records are always defective. The geological records truly reflect the changes in the animal and plant worlds from one period of geological time to the next. Many of the new species evolved in the wake of a global catastrophe at the beginning of a new age, and were entombed in a subsequent catastrophe of nature at the end of that age. The fact that in many cases the transitional links between present-day species are missing, as well as those between various species of the geological record. A vexing problem is understandable in the light of sudden and multiple variations that gave rise to new species. It was objected that if a new characteristic appeared in only a single animal, as the theory of natural selection claims, or even in a few animals of the same species, it would disappear in succeeding generations through interbreeding unless the new animal had been protected by isolation on secluded islands. However, in catastrophic evolution, the simultaneous mutation of many genes could produce a new species at the first fertilization. All the offspring of a litter could be affected. And it is not inconceivable that in more than one creature of the same species, under similar circumstances of radiation, similar changes in the genes would occur. So, in the X-ray experiments on Drosophila, similar mutations occurred in more than one fly. The fact stressed by Agassiz that numerous earlier species of fish showed a more highly developed organism when compared with later species of fish can be explained by the destruction of earlier forms, not in the process of competition, but in upheavals against which superior adaptation is of no defense. The observation that healthy species of animals like mammoths with no sign of degeneration suddenly became extinct greatly troubled the evolutionists. This fact is unexplainable by natural selection or the principle of competition, not so by the catastrophic intervention of nature. The puzzling observation that the larger animals were particularly subject to extinction, like giant mammals that succumbed at the end of the Tertiary and again in the Pleistocene, is understandable if one thinks of the better chances smaller animals have of finding refuge from the ravages of nature. Natural selection had its role too, but not in procreating new species. It was a decisive factor in the survival or dying out of new forms, in the struggle for existence, not only between individuals, races, species, and orders, but also against the elements. In natural selection, all those forms were weeded out that could not meet competition or the rapidly changing conditions of a world in turmoil. The origin of new species from old could be caused by the same processes that can be duplicated in laboratories, by excessive radiation, thermal or chemical, in abnormal doses, all of which must have taken part in natural catastrophes of the past and could have played a role in building new species, as the case of new plants in the bomb craters appears to indicate. The theory of evolution is vindicated by catastrophic events in the Earth's past. The pronounced enemy of this theory proved to be its only ally. The real enemy of the theory of evolution is the teaching of uniformity, or the non-occurrence of any extraordinary events in the past. This teaching, called by Darwin as the mainstay of the theory of evolution, almost set the theory apart from reality. Great catastrophes of the past accompanied by electrical discharges and followed by radioactivity could have produced sudden and multiple mutations of the kind achieved today by experimenters, but on an immense scale. The past of mankind, and of the animal and plant kingdoms too, must now be viewed in the light of the experience of Hiroshima, and no longer from the portholes of the Beagle.